Hey there, welcome back. So in this video, I'll cover the left view of binary tree. So what is this about is, let's take an example so that we'll better understand what this problem is about. Okay, let me take an example of like one tree. So let's take this as something, right child as 3, again some 4, let's make this as 5 and 7, something like this. Okay, so assume this is the example that we are given, and we should be able to output the left view of this tree. Okay, left view is nothing but assuming the user is seeing in this direction. Okay, so if he's seeing in this direction, the things that will be visible for him is okay, is this one, and then this one, and this one, and this one. Okay, so the output for this example is, if it's a left view, 1 2 4 6, that is the extreme left things of a tree would be visible for him, that is this part. Okay, so now this is the output that we should be able to print given the binary tree for us. Okay, so if we observe closely, in every level, the first node you see, that is what the output we should print. Okay, so how are we going to achieve this? It's nothing but just the pre-order kind of traversal, but with one extra keeping track of, that is we should keep track of the level. So assuming this is level 0, and this is level 1, this is level 2, this is level 3, and so on. That's like for every child we are increasing the level by 1. So so how are we going to achieve this? Assuming initially we are at this root node, so pre-order traversal always parent first. So what we do is we will print this first. Okay, so here we will print this one, so then go towards left. So check, this is the first node in this level 1 that we are exposing visiting. Yes, so what we do, we print 2, again go towards left. Okay, so this is again first node in this level 2 that we explore, then print this 3. Okay, so there is no, again go for left, nothing is there, right, no, so we return to its parent. Okay, again go to the right part, this is not the first node in this level, so we again go to its left node. This is is it the first node in this level 3? Yes, so we will print this 6. Again check for its left node, nothing, right node, nothing, so we return back to its check for right node, nothing, so we return back here. This is already done, so we move back to its parent. Is there a right child? Yes, we go to its right child, check for its left child, nothing, so we return back to its 3. And before this even checking for the left child, we check was this the first node in this level 1? No, first node was already 2, so we will not print this. Okay, again go for its right child, we'll go to this. Is it the first node in this level 2 that we are exploring? No, so we will not print this. So check for its left, that is nothing, go back, and check for its right, nothing, so go back. Okay, so this is how the traversal of this would look like. So I think if I write the pseudocode and explain the calls, how it will happen, I think that will be better eye opener than if there is any confusion with the explanation I have just made. So let me write a simple pseudocode. So left view, something like this. Here we'll pass the root node and also the level at which we are, and something like let's say one array to keep track of that left view traversal. Okay, similar the base condition remains same. If root is none, we will return. Obviously for recursion function we should have the these conditions. Okay, if root is null we will just return, and then since it's a pre-order traversal we'll check here the condition is this is the core, so at level initially will be at level 0, right? And also the result array will be also having nothing, that means the length of it will be 0. What we will check for the first node, the logic to check for the first node in each level is we will compare the size of this result array to the level. If they're matching, that means that is the first node, we are at that level. Okay, then we will push that value into this result, that is if result size equals to level, we will push into result. Okay, and then pre-order traversal, then go for left child, that is root to left, and for every child exploring we will increment the level by 1. Okay, and pass the result array, and then the right child exploring, so this is right, and level +1 and result. Yeah, this is the pseudo code. I think I know the handwriting is worse, but yeah, so this is the thing. So now let's explore the using stack, I mean the function calls, how it will happen. Okay, so initially the this response array is nothing, so it's empty. Okay, empty, so whatsoever, so just infinite something empty. Okay, so first stack would be like this, we will be at this node 1, so here, so now is root equals to null? No. And result dot size is 0, and also level is 0 initially, as I told again. So they are both equal, 0 equal to 0, yes. Then we will push this one into result, that is 1 will be here. Okay, now we'll go for the left child of this root node 1. Left child is 2, so I'll push that left child. Again check for it's null, no. So again check for, now the result array size is 1, and also level we incremented by 1, so that level is also 1. So is 1 equal to 1? Yes. So then we will push the 2 as well into our result array. Okay, now again left child of a 2, so left child is 4, so we will push into this, check if this is equal to null. No. Again the level we incremented by 1, so level became 2, and the result size also became 2, so they both are equal. Again we'll push the 4 into the result array. Okay, now check for the left child of root node 4, will that is null, so I'll push the null here. Again it's null. Okay, so what will happen, we will return here. So next the array becomes like this, that is, let me draw this itself, 1 2 4. The same thing happens for right child, that is also null, so I'll push the null here. Again this also will return. Okay, so finally what will be the stack is like this, 1 2 and 4. Okay, so now 4, so that is done. So the function calls left and right child is explored, so this will be taken off the stack. So this is how it will be, that is 1 and 2 now. Okay, 4 will be taken off because that is done. So now 2, so left child of 2 is done. So now we'll go for the right child. Right child is 5. Okay, 5. Okay, it's 2 5. Again we'll check now, is it equal to null? No. Again now the result level is 2. Okay, and result size, response array size is 3, so is 3 equal to 2? No, right? So then we will not push into the result array. Okay, so then we'll go for the left child of 5. Okay, left child of 5 is 6, so I'll push, so here I'll push 6 here. That is 1 2 5 6. Okay, level became 3 here. Okay, so level became 3, and now is 6 equals to none? No. Again level 3, and the result array size is 3. Is 3 equal to 3? Yes. So I will push 6 into result array. Okay, that is how it happens. Again now we'll check for the left child of root node 6. There is nothing, so null. So we'll return back to 6 again. Check for the right child of 6, null, return. So the work of root node 6 is done, so we'll take it off the call stack. Okay, so like this, 1 2 5. Okay, and similarly go back to its root node 5. Again check for its right child, null. So we'll return back to its 5. The exploration part for the root node 5 is also done, so we will take that also off the stack. Okay, so this is how it will be. I mean 1 2, this will be taken off the stack, 5 1 and 2. So 2 is also done, so I mean we done exploring the left child and right part of it, so this will also be taken off the stack. Okay, so same goes for the now right child. Is there a right child for root node 1? Yes, there is. So then we'll push that node here, 3. Okay, so 3, and the level is 1 here for this. Okay, and is 3 level 1 is equals to 4? No, so we'll not push this. So we'll explore the left child. There is no left child, so we'll return back to its parent. Again explore for the right child. Yes, there is right child, so we'll push that right child like this. 3 7, and here level is 2. Is 2 equals to 4? No, so we'll not push this. Again we'll check for the right and left child, sorry, left and right child. There's nothing, so this the node will be exploration part is done, so I will take it off the stack. So move back to its parent. So this will be taken off the stack. Okay, and 3 exploration is also done, so we will take that also off the stack, and 1 is also done, so this will also be taken off the stack. So that is it for this explanation part. So now if you see the output, the 1 2 4 6, that is exactly what we needed, right? So this is the explanation for this left view part. The only the trickiest part is like we should keep track of the level of the node, and also check with the size of our resultant array. So that is the like every just to keep check of is it the first node we are exploring in that particular level. Okay, so this is the explanation. So now let's jump on to our code part and execute this pseudo code and see if the output is matching to 1 2 4 6 or not. Okay, so yeah, so let me start writing the code. Okay, I have created a leftview.cpp. So let me import the headers. Okay, that is IO stream and the vector. Okay, and then that namespace, and define the node. Okay, so var, and then the left and right pointers. Okay, and then we write the function that is left view. I'll name this as left view, and we'll pass the root as well as the level of that particular node, and then the array like left view left as a array, Now the first base check is root equals to none. We will return it, okay? Or else what is the check is, if level is equals to left dot size, okay, then I will push that root node value, okay, that is root value, okay? Or else we will keep exploring the left side first, then the right side, okay? That is left view root level plus 1, and then that pass the left array, and then do the same for right this is root to left, okay, and this is root to right, and then increment the level by 1, and then pass that left array, okay? So this is the function, and then as usual we'll write the function to create a new node, okay? So that is struct node new node, and we'll allocate memory for the node, okay? That is of size struct node star, and this would be of size of that struct node, okay? Yeah, so now we will assign that value here, and to value is value, and left and the right pointers I will make them as null, and finally return this temp node, okay? So this is the function to create new node. Then finally we'll write the main and create the example structure which I just explained, and see if the output is matched or not, okay? So let's name this as root new node 1, okay, and the example, okay, so root to left is new node 2, okay, root to right new node 3, okay, then root to left is 4, then root to left to right is 5, then one more on in root to left to right to left is 6, and then one more node, that is root to right 7, okay? So this is the tree structure of our example. Now I will define this array, that is, so let me initialize of left, okay, and then call that left to view function by passing the root and initial level as say 0, and then pass this left, okay? Then we'll check the print this left view traversal of the tree, something like that, left view traversal, and now I'll traverse the left array and print the value vertex index and see if the output is matching or not, okay? So dot size this one, and then print that value at that index, okay? Finally return, okay? So this is it. So let's check now. So let's execute and check this output is matching or not. So yeah, so if you see, the left view traversal of our example was 1246, which is exactly we see here in the output. Yeah, okay. So this is it for this video. Thank you for watching, and keep watching my channel. There will be a lot more videos coming up on this channel. Thank you.